So this problem says a 500 ohm resistor and uncharged 1.5 microfarad capacitor and a 6.616 volt EMF are connected in series. So there's the circuit. So this is 6.16. 500 ohms and 1.5 microfarads. Okay. What is the initial current? What is the initial current? What is the time constant? What is the current after one time constant? What is the voltage or the on the capacitor after one time constant? Okay. You saw in theory class that the charge on the capacitor builds like so: CV 1 minus e to the power minus t by RC, and QT is CV times 1 minus e to the power minus t by, that's the time constant. RC is the time constant. Okay, that's how the charge builds on the capacitor. Okay, so the charge is building because of the current flowing, and the current at any time is given by dq by dt. Okay, and you take the time derivative of that. That is the time derivative of this is 0. The time derivative of that gives you 1 minus 1 over tau. Okay, so that gives you CV times minus 1 times minus 1 over tau e to the power of minus t tau. So CV divided by tau e to the power. Okay, and well, I'll just do it. Okay, so the current at any time is CV, tau is RC, so the current is exponentially dying. Okay, and equal to V over R. Okay, and you have this expression in your notes. I just re-derived it. Okay, so let me say, let's look at this expression. At t equal to 0, this is 1. At t equal to 0, this is 1. And that would be the current in the circuit. V over R would be the current in the circuit if the capacitor was not present. And that would be the steady state value. Because the capacitor is present, the current is dying exponentially as the capacitor is getting charged. Okay, and so at t equal to 0, the current is V over R e to the power minus 0, which is V over R. And that's equal to 6.16 volts divided by 500 ohms. Okay, so the initial current in that RC circuit is 0.0123 amps equal to 12.3 milliamps. Okay. Then part B says, what is the time constant? What is RC? Time constant is RC, which is 500 ohms times 1.5 microfarads. Okay, and ohms times farads is time, seconds, so this is 750 into 10 minus 6 seconds, and we'll write this as 0.75 into 10 minus 3 seconds, 0.75 milliseconds. Okay, what this tells you is everything changes on the time scale of roughly well, the time constant of the circuit is 0.75 millisecond. Stuff changes on the order of 1 millisecond. Okay, what that means is after 0.75 milliseconds, this would be 1 e to the power minus 1. This would be 1 over e. This would have charged to 65%. 1 minus 1 over e is roughly 0.65. So after 0.75 millisecond, the capacitor is charged to 65% its maximum value. Okay, so the time constant is an important factor in all these circuits. So Qt charges like that, and after one time constant, it's charged to about 65% max charge. Okay, 0.65 times the max charge. So that's what the time constant means. Okay. All right. What are they asking? What is C? What is the current after one time constant? C. The current after one time constant is one time V over 1 over EV over R. Okay. 1 over E times I naught. I naught is the current at time t equal to 0. And we found that. Okay, so, and I will, let me do 1 over E for you guys. So this is 0.37. Okay, the reason I did this is after one time constant, after one time constant, the current is 37% the maximum value. Okay, so that's what's happening. Okay. And then part D, what does D ask you? What is the voltage on the capacitor after one time constant? So D. Okay, the voltage on the capacitor is Q over C. So voltage across the capacitor is the charge across the capacitor divided by C. That's CV 1 minus e to the power minus t by tau by C equal to V times 1 minus e to the power. V is the voltage of the battery. Okay? And so the voltage across, we'll call it V naught. Okay? Just so there's no confusion. One minus e to the power of minus tau by that's the voltage at you guys. So from this expression you can see that at t equal to infinity this would be 0, and the voltage across the capacitor would be equal to the battery voltage. Yep. So after one time constant, the capacitor is charged to 3.9 volts. Okay. All right. So